80, remove duplicates from sorted array 2. So for this problem, we are giving an array nums, but we must do the operation in place. So this means we cannot use any actual memory. So the idea is that we cannot have at most 2 consecutive numbers. Yeah, let me just read it. So we are giving an integer array nums sorted in non-decreasing order, so it's going to be in increasing order, and we're going to remove duplicates in place such that its unique elements appears at most twice. The relative order of the elements should be kept the same. Yeah. Now we can try to solve it. Basically, we need to solve the problem in place. It means we need to use one actual memory. Yeah. So the idea is that from the beginning, we have 3 ones, but that is not possible. This means we just need to remove this one, and this 2 going to be here. And similarly for the next 2. But we cannot have 3 2s, so we can only have 2 2. We just remove this one, and we have another 2 2. And then we're going to put 3 here. And after that, there are going to be no integers. So we're going to return the final index. So it's going to be index 5. So we have 1 1 2 2 and 3. So after 3, there's no such numbers because we've already moved the 3 to this place. But from here, there's no such index. So this means we just needed to return as the final result. Maybe there are some other numbers, maybe 3 or 4. It doesn't matter. We just needed to keep the previous all the previous numbers. So that is okay. Yeah, because it doesn't matter. So for this example, we have 0 0 1 1 2. Because we only have 1 2, so 2 gonna be here, then 3 3. Even here we have empty space, maybe some numbers. It doesn't matter. We just need to return I for this index. It's gonna be 7. Normally, if we wanna solve a problem in O1 space, it's gonna be a little bit difficult to think about. Yeah. So here we can at most have 2 consecutive same numbers. Yeah. How can we solve that? We're gonna prepare index gonna equal to 2. Because basically for the first number and the second number, it doesn't matter. We're gonna check from the third number. So we're gonna check from the third number. Yeah. So if this number is not equal to the previous numbers, but the previous numbers are gonna be nums I minus 2 instead of I minus 1. So for example, for this number 1, actually I don't need to check with this number because it doesn't matter. I only need to check if it is not equal to the number, the previous of the previous number. It is going to be this number. Yeah. So for example, currently I have this number 1. I don't need to check its neighbors. I need to check the previous of the previous number. I mean, it's going to have a distance of 2. I'm going to check this number. So if they are not equal, definitely it's not valid. We have to do something about it. Yeah, so if they are equal, so if they are equal, we can jump. Go to the next number. We can continue to check. But if they are not equal, definitely we can do some operations. Yeah. So for example, here, this one equal to this one. This is okay, but we've already recorded the place. It is here. It means from this place, definitely we want to use another number to cover this position I. The I gonna equal to 2 from the beginning. Now we're gonna check the next number 2. So 2, we're gonna check 2. Is this number 2 equal to I minus 2? It's gonna be I minus 2. It's gonna be this first number 1. So because I equal to 2, 2 minus 2, it's gonna be 1. So this 2 not equal to 1. Definitely I need to use this number. Yeah. So this means from here, if n not equal to nums I minus 2, I need to use this number. So this means nums I is going to equal to my current number, and I'm going to need to update the index. Finally, I need to return the index. Yeah, so this is the basic idea. So we're going to check, let me use some examples. 1 1 1, 2 2 3. So this is our index I, because for the first and second it doesn't matter. Even they are equal or not equal, it doesn't matter. Yeah, because if we only have 2 numbers, definitely it is valid. I gonna be here. I gonna return a 2. Definitely it is valid. Yeah. So yeah, let me just continue. But yeah, let me just continue. We're gonna check from the index I equal to 2 for this one. So if they're equal, I'm gonna check the next number. So currently it is this one. I'm gonna check the number. It is a 2. So for this number 2, I'm gonna check if this number 2 equal to the nums I minus 2. It's gonna still be this number from here. Yeah, 1. Yeah. So if this number 2 not equal to 1, so definitely this means yeah, definitely this means I have too many ones. I need to cover with another number. Yeah, so if this is not equal to this one, I minus 2, I is here. Yeah, I need to cover with this number. So currently this one gonna be 2, and I gonna equal to 3. So this gonna be I gonna be here, I equal to 3, and I will jump to the next number. And I'm going to continue to check. So for this number, is that equal to I minus 2? So for I is here, I equal to 3, 3 minus 2, it's going to be index 1. So this 2 not equal to 1, right? Yeah, it means definitely there's going to be some duplicate. At least it's going to have a, not duplicate, it's going to have 3 consecutive numbers, 3 same numbers, 2, 2, 2. So this means definitely we need to cover this number with 2. So for here, nums I gonna equal to this number n, yeah, and I gonna be here. Now I'm gonna check the last number, which is gonna be 3. I'm gonna check if 3 equal to I minus 2, I minus 2 gonna be here. So 3 not equal to this number 2, so I minus 2 gonna be here. It means we have 3 2s. If 3 not equal to this number 2, so this means from this place I need to have a 3. So in this way, I gonna keep at most 2 same numbers. Yeah. So this gonna be the final I. So I gonna be updated to here. And currently I have no numbers. So I'm gonna return the final index. So it's gonna be 5. So this is the basic idea to solve the problem. Let me just run it and submit it to check if it can pass for all testing cases. Yeah, I know this is going to be a little bit strange for this kind of formula. Actually, this is for checking if we have 2 consecutive, 2 same numbers in sequence. We're going to use this kind of formula to check. Yeah, as you can see, it passed for all testing cases, and it is in place. I think that's all about it. Thanks for watching. See you next time.